So another type of gravimetric analysis is called the precipitation analysis. So this is the more common gravimetric analysis that we have encountered. So the principle of this one is your analyte, from your analyte, you allow that to react with a reagent to form a solid product. And then ang kanang solid product, you can collect the solid product and you measure the mass. So that's the principle of precipitation analysis. So ang accuracy aning precipitation analysis depends on the property of the solid product. So first, these are the desired properties of the solid product. Okay, so first, they should be very insoluble, meaning that all of the analyte must be converted into solid product niya. Dili siya mobalik o ka-convert in solution. Okay, so that means it should be very insoluble. Okay, it should not be partially insoluble. It should be very insoluble. Okay, and they must be easily filterable, which means that preferred na to ang large crystals. And they must be very pure, of course, para you won't get a kanang false nga data. And the composition of your product must be known and it must be constant. Okay? So, very few precipitates have all of these properties, but in most cases, appropriate techniques can help optimize these qualities. Okay, so that is why gravimetric analysis requires skill. So let's go to the solubility. So we have to improve the solubility of the precipitate, diba? So the solubility of a precipitate must be decreased. Kay we want something that's not soluble. It should be very insoluble, diba? So it should not be soluble. So we need to decrease the solubility of the precipitate. And to do that, we can decrease the temperature of the solution. So decrease the temperature, or we can use a different solvent. So we don't need to use water all the time. We can use another solvent such that katong nga precipitate will not be soluble in that solvent. Okay, so usually we can use less polar or the organic solvent. Okay, so this is the trend of solubility versus pH. So for example, for calcium carbonate man is soluble when in higher pH. So ang iyang solubility decreases kung mataas ang pH, diba? So ang appropriate, so you should be able to know kung unsa ang appropriate nga kanang pH to precipitate calcium carbonate. Okay, so because its solubility decreases at pH 10 to 12, somewhere here, diba? It has the lowest solubility, so it's best to precipitate. If you want to precipitate calcium carbonate, it's best to precipitate it at this pH. Okay, if acidic ang pH, around acidic pH, like around pH 5, dako man iyang solubility. So if dako iyang solubility, you won't form calcium carbonate nga precipitate. Most likely, mo dissolve ang calcium carbonate. Okay, you also have solubility versus common ion effect. You've encountered this from the previous nga module. So for example, ang magnesium fluoride. So for magnesium fluoride, if it's mixed with sodium fluoride, diba? The fluoride is the common ion, diba? So ang solubility of magnesium fluoride will decrease. So magkagamay iyang solubility kung magka-increase ang common ion. Okay, so at this point nga nakay 0.12 molar of sodium fluoride or 0.12 molar of fluoride ion, the common ion. So ni-decrease ang iyang solubility. It went down to 10 raised to the minus 8. And also, you have solubility versus temperature. So these are the factors, okay, that can affect the solubility of a substance, of a precipitate. So versus temperature, so for example, for KCl, for example, KCl, the solubility increases at higher temperature. For KNO3, solubility increases at higher temperature, so it's best to do it at lower temperatures. Okay? In precipitation analysis, it's governed by KSP. So, for example, for AgCl, the KSP of silver chloride is 1.8 times 10 to the minus 10. Diba? So, for the solubility of sodium chloride, silver chloride, solubility of silver chloride, you expect in the solution, you will have the solubility, this is the this is the mass balance equation. So you need you don't really need to do that, but in this case we're showing you it's showing you the mass balance equation. So that's Ag plus AgCl plus AgCl2. That's the solubility of AgCl, di ba? Kay una, you will have silver ion o chloride ion that will form AgCl. AgCl nga aqueous, di ba? And ang equilibrium constant ana is this one. Then yung AgCl nga aqueous mo form siya og AgCl nga solid. That's the intrinsic solubility. So the Ki, it's AgCl. So intrinsic solubility na. And then you have the complex ion formation. You have AgCl niya mo bind pagid siya og excess chloride. You have AgCl2 minus. Okay? So the gravimetric analysis for specifically sa precipitation analysis, it's governed by KSP. So arin nimo magamit ang KSP in the case of precipitation analysis kay mo form man jud ka og precipitate, diba? That's why it's called solubility product constant. Okay, so filterability. Okay, another thing that we need to optimize is that the precipitate must be filterable. So filterable doesn't mean really big precipitate like large crystals. We don't really want like very large crystals because ang tendency, if very large protein crystals, we might have kanang impurities nga na-occlude sa sulod sa crystals, diba? So we want large crystals, of course, because that's easier to filter, but we want large pure crystals. Okay? So good quality nga precipitate. So we want these products to be large enough to be collected on filter paper. Nga dili sila masulod sa pores sa filter paper, and they should not clog the filter, or they don't pass through the filter. Okay, so ang best jud ani nga case are pure crystals, whereas ang worst ani nga case is if you form colloidal suspension. The colloidal suspension are difficult to filter because their size are very small. That's why it's called a colloidal suspension, kay small ilang size. So, ang tendency man god, if you form colloidal suspension instead of pure crystals, if you don't see crystals but you form suspension instead, then they tend to stay in solution indefinitely. So, they can only be suspended by Brownian motion. So, the size of these is usually 1 to 100 nanometers in size. Diba? So, they're already very small to be filtered by kanang the filter paper. So it will be difficult to separate the colloidal suspension. So whether crystals or colloids are obtained depends on conditions used in the precipitation. Okay, so we can optimize the formation of these over the formation of this. Okay, so it depends in the precipitation, the conditions. So in precipitation analysis, we have to consider the process of crystal growth. So, sa pag-grow sa crystal, because we want to form crystals instead of suspensions, colloidal suspensions, right? So, to form the crystals class, nanay duha ka ways. We have nucleation, particle growth. These are phases there. nucleation of particle growth. So ang nucleation class is that ang molecules in solution come together randomly and form small aggregates. So ang kuan ng nucleation class is if nakay usa ka buok and then if nakay usa ka buok nga murag mao na ang stimulus nga mo aggregate dira ang uban, mao na maka-form ka dira og crystal. And then if you have more than one murag kanang source of the nucleation center, murag inana. So if you have more than one, that means you will form more nga small aggregates. So you will form small aggregates. Okay? Mo na ang process ng nucleation. For particle growth, addition of molecules to a nucleus to form a crystal. So gikan sa nucleation, ang particle growth kay mo add siya more ana katong sa ni-nucleate, mo add siya more, mo nang mo-grow ang particle, mo dagko. Depending on the speed of the nucleation of sa particle growth, kung asa ang nagpalabi ani nga duha nga phase, that will determine kung unsa kanindot ang imong crystal for nga imong maway. Unsa kanindot ang quality sa imong crystal. Okay, so it depends on these two phases. Okay, so nucleation and particle growth always compete for molecules or ions being precipitated. So, kung mas paspas ang pag-nucleate, mas daghan ka og small aggregates compared sa kung paspas ang pag-nucleate compared sa particle growth ba. So, if this is faster, if nucleation is faster, you will have more small aggregates that's occurring, which will give you colloidal suspensions because you will have kanang nucleation is faster man. So mas mupalabi ni siya. But if particle growth is faster than the nucleation, then you will have few of those large particles which will give you crystals. So you have first nucleate siya but paspas man ang particle growth, so it will just add to the single nga ni-nucleate, di ba? So daghan ang inana. So daghan ang large crystals compared sa if nucleation, you will have small because paspas man sila, so mas daghan but gagmay. That's why you form suspension, a colloidal suspension. So from a colloidal suspension, because you don't want colloidal suspension because they are difficult to filter, diba? So you want to convert that into crystal. You would want to form crystals instead of colloidal suspension. So you want crystal formation. So you have to modify the conditions. Now, we need to, because colloidal suspension, these two differs in the rate of nucleation and particle growth, diba? Kung unsa kapaspas ang nucleation of particle growth. So we have to change the conditions such that mo favor sa particle growth compared sa nucleation. Okay? So the rates of nucleation and particle growth depends on the amount of precipitation solute present. Okay? And this amount of precipitation solute present is described by a quantity known as relative supersaturation. Ang formula sa relative supersaturation is R is equal to the concentration of equal to actual concentration of solute. So this is the solute that you added to the solution minus the concentration of solute in solution at equilibrium over the concentration of solute in solution at equilibrium. Okay? So if ang value sa R, if this R value is large, so this will favor nucleation and colloid formation. So kung dako ning R, meaning gamay ning S, di ba? So that's gamay ra ang concentration sa solute in solution at equilibrium. Okay? So this will favor nucleation. Therefore, kung mo favor siya nucleation, mo favor siya og colloidal nga formation. We do not want that. So in gravimetry based on precipitations, a small r is desired. So we desire small r which is approximately 1.0. So as much as possible, ang ratio will be equal to 1 such that mo favor na siya og crystal growth. Okay? So this is the boundary of ionic atmosphere. So here you have silver chloride. So these are silver chloride, silver ion chloride, chloride, silver. So this is the silver chloride nga precipitate. Okay, so in a colloidal particle class, in a colloidal particle, see this is a silver colloid nga ni form of silver chloride nga ni form of colloid. So ang tendency is katong mga laing positive they will surround this, you know, the nitrate o kaning H+, they will surround your they will also crowd the colloid. Okay, this is the boundary of ionic atmosphere. So dili na maka-attach ang silver o ang chloride. So dili na maka-attach because it's crowded with another ions, diba? With the spectator ions. You don't want this because this you would want nga maka-attach pa dira ang silver chloride kay para mo dako ang imuhang crystal, diba? So there from here we know that we would want our value to be as much as possible equal to 1, smaller our value, diba? So to minimize R, we have several methods. So we can increase the temperature of solution. So if we increase the temperature of the solution, the concentration of solute in solution at equilibrium will increase, diba? So kung mudako ni ang S, mugamay ang R, diba? Kay if i-increase na to ang temperature, mo increase man ni ang concentration of solute in solution at equilibrium. Kay mas ma-dissolve man ang solute kung higher ang temperature, diba? So we can increase the temperature of solution, which will increase the S, and it increases the amount of solute. So because R is equal to Q minus S over S, then if we increase this one, then this will decrease. 2, we could add precipitating agents slowly while vigorously mixing the solution. So ang effect ani class, if hinayon nimo og add ang precipitating reagent, this will avoid local high concentrations of solution. So if hinayon nimo pag-add ang reagent, ha. So if hinayon nimo ang pag-add ang reagent niya, vigorously stir nimo ang solution. That means nga ang reagent, because you're vigorously stirring it and you're slowly adding the reagent, ang reagent will most likely attach to that katong ion nga iyahang dapat should attach. For example, silver chloride, and you're adding the silver nga reagent, then the silver will react with the chloride. Okay, it will not be surrounded by the spectator ions. So it will not create more nucleation. Diba? It could avoid nucleation, and therefore, if ma-avoid na to ang nucleation, it could also avoid colloid formation. Next is that we can keep the volume of the solution large. Diba? So if you keep the volume of the solution large, it could keep the concentration and analyte and the precipitating reagent low. So if low ang concentration sa analyte ug precipitating reagent, then less likely nga mo form og mo high ang nucleation nga process. Okay, gamay ra man ang concentration sa analyte ug sa precipitating reagent, di ba? So actually it's just like this one. Kini sila almost the same. So what you're doing here is gihinay-hinay ni mo add ang reagent. So it's just like this one. But ang technique dire is they just keep the volume of solution large. Next is to control S through chemical means. So you can adjust pH, you can add complexing agents. So for example, if you precipitate calcium oxalate, so calcium CaC2O4, if you want to precipitate this one, you just need to decrease the pH of the system. So as pH changes, the solubility of CaC2O4 changes. Okay, so if you notice, giada niya daan og acid. Okay, so because the pH, diba, as we have shown earlier, solubility and pH nga relationship. So there's a relationship between solubility and pH. So some substances are less soluble when it is at lower pH, or they could be less soluble at higher pH. Okay? So another thing is homogeneous precipitation. So so gikan ta process of crystal growth, di ba? Next is homogeneous precipitation. What this means is that the precipitating agent, so ang katong reagent nimo, is generated directly in solution by means of a chemical reaction. So ang ideal case ani for precipitation, the agent is generated uniformly throughout the solution. So wala jud kay excess, di ba? Kay if you add something man god, if for example nakay chloride imong analyte and you want to precipitate it with silver, you need to add excess silver para mahurot jud ang chloride, di ba? So you will have excess silver ions in solution. The advantage of homogeneous precipitation is because ang silver is produced in the solution, directly sa solution, kung asa na nag-contain imong analyte. Because the reagent is directly produced in solution, then you won't have kanang excess ng reagent, di ba? So you can avoid the presence of this excess reagent. And for example, so we have urea. Okay, so urea in water. So as you produce OH, ang pH kay mo gradually mo increase ang pH because you're producing a base, di ba? So the presence of this OH, or the increase in pH, will precipitate a number of compounds, like for example CaC2O4. Okay, so this CaC2O4 was precipitated kanang via homogeneous precipitation because of kanang increase man nimo ang pH using this process, the presence of urea. Okay, so next is these are miscellaneous notes on precipitation. So most ionic compounds are precipitated in the presence of some added electrolyte. So for example, HNO3. So this will allow the small nucleation aggregates to better overcome any charge repulsion, and so it will promote particle growth. Okay, so next is the impurities may also be present in the crystal. So it's called co-precipitation. So ang precipitate kay ang impurities kay maapil siya og sulod sa crystal. So for example, ani, so you have this one, and then una pa musud ang AG diri na kay occlude nga kanang impurity. So we have different types of impurities. You have adsorbed. So adsorbed meaning sa surface ra siya, and then you also have a Cantor ion. Okay, so adsorbed impurities are trapped within pockets of crystal. This is called occlusion. Okay, so for example, nasud siya. This is your desired nga ion. Okay, this is your desired nga analyte, and then nasulod ang ni-occlude ra ang impurity. Okay, so that's what we call as occlusion. So impurity is similar to the analyte or reagent. And then that's usually jud ang masud na ana kay kanang similar properties. So for example, if positive dapat unta ang nadira, positive pud nang impurity. Okay? Next is impurities placed in the crystal instead of analyte. So this is what you call as inclusion. So sa crystal jud siya mismo. So di ba, you have, for example, you have NaCl crystal. ang ang structure sa NaCl crystal is that na kay Na plus dira Cl, NaCl. So na-appeal gid siya sa crystal. So ni-fill gid siya sa usa ka space sa crystal. Okay? That's what you call as inclusion. Next, impurities are of course undesirable kay ma-appeal na nimo og way. So it could change the chemical composition of the precipitate. Although this rarely happens, but this could happen. It could change the chemical composition. And it causes errors in the analysis. Kay imong matimbang og appeal ang impurities. It will be difficult to remove that. So to minimize impurities, you have to keep R small. So you need larger pure crystals. And you need to decrease occlusions and adsorb impurities. So how do you do that? Digestion. Digestion is a process of allowing the precipitate to stand in mother liquor or the precipitating solution, usually while being heated. So, example, you're precipitating silver chloride. So, na precipitate na dira ang silver chloride. But, a possibility is that the sodium chloride, silver chloride precipitate silver chloride impurities precipitate contains impurities. Okay, so if it contains impurities, you can do digestion. So ang process of digestion is you allow this silver chloride precipitate to just stay here. So this is what you call as the mother liquor. Kung asa na siya ni precipitate, this is what you call as the mother liquor. So imo ra nang i-heat, allowed to heat, and then you just allow that to stand niya, i-heat. That's what you call as digestion. So what will happen the class is that it will promote the removal of impurities from crystal. Okay, so also aside from that, it could also increase the size of crystals. So you just allow that to stand. Okay, that's what you call as digestion. And then you have to wash the precipitate and redissolve the precipitate in fresh solvent and then reprecipitate. So this could help decrease all types of impurities, whether it's adsorbed, whether it's occluded or included. Okay, so washing and redissolving the precipitate in fresh solvent and then ibalik nimo og pa-precipitate. That will usually decrease all types of impurities. Okay, and another thing is adding a masking agent to solution. So, in this case, ang precipitant nato is kining CpCH, okay? And ang masking agent is cyanide. So, the function of the masking agent is to keep the impurities from precipitating, okay? But not the analyte. So, ang masking agent na to, we don't want Mn because we might form MnCpCH, right? We might form, instead of ang Mg ang mo form with CpCH, instead of kana ang mo precipitate, it's a possibility nga mo precipitate po ni. So we can add masking agent, so kini like ang cyanide, para ang cyanide may mo react with this will be the impurity, okay? The manganese ion. Okay? Para mo form siya og separate nga compound. Okay, so ang imong makuha-create nga solid product will be just this, imong desired nga solid product. Okay? In washing precipitates, so precipitates from ionic compounds, they need electrolyte in wash solution and they will keep precipitate from breaking up and redissolving. This is what you call as peptization nga process. And then electrolytes should be volatile. So they could be removed because they are volatile, then it means that they could be removed by drying. Okay? So it's good to wash them with like for example ethanol and methanol, and you also have nitric, HCl, ammonium nitrate, etc. Okay? Then you have AgCl. Should not be washed with water. Instead, you wash it with HNO3. Okay, so HNO3 is volatile. It's a strong electrolyte. Okay, kay iba strong acid siya, so it's a strong electrolyte. Next is in drying. So, after nimo pa-precipitate, di ba, ang process is ipa-react nimo ang analyte with reagent, and then after mo react, then it will form the precipitate, di ba? Then after forming the precipitate, you need to filter that, and after filtering, you need to wash. But of course, you need to wash the precipitate, and depending on the precipitate, then you have to wash it with the proper nga washing agent. So for example, like this one, ang silver chloride, you need to wash it with nitric. So usually, ang imong gamiton pang wash are ionic compounds. Volatile, okay? Volatile nga substances ang imong i-wash. After washing, you need to dry or to ignite. Sometimes you need to ignite. So you need to dry the precipitate. So many of those precipitates contains water, kanang gikan pagid sa mother liquor, and many of them contains adsorbed water. So they are called hygroscopic compounds, meaning they absorb water from air. Mo-absorb sila og moisture from air. So they're called hygroscopic. So for accurate stable mass measurements, these precipitates are dried. So as I've said earlier, ang precipitates, when you do gravimetric analysis, ang precipitate, they must be weighed many times. Okay? Dili lang kaisa. They must be weighed hangtod nga ma-constant na ang weight. And then precipitates are also ignited to convert to a given chemical form. So, for example, this one. Kini nga compound, this iron, I don't know how to, FeHCO3. This one, this compound is kanang nagay, it's hygroscopic, so it has water molecule attached to water molecule nga adsorbed. So if you heat that at 850 degrees Celsius, then it will be converted to Fe2O3, which is more stable niya, kanang no water nang kanang present. So na-remove na ang water ug ang carbon dioxide. Diba? So when you weigh this one, this will become more accurate. The scope of gravimetric analysis is that it is accurate, it is not expensive, so ang major component equipment is just the balance, because you need to weigh that, of course. And the advantage, however, is that it's more tedious than other approaches. So you have to carefully consider how to minimize potential interferences. Kaya diba, you have to make very good crystal. The crystal should not be the crystal should not contain impurities as much as possible. So you actually have a table for that. So you have, for if the species, for example, if you want to analyze, if your analyte is potassium ion, then you can precipitate it in this form and you can weigh it in this form. So ang interfering species ana kay kini sila, so you need to think about how to remove these interferences.